My name is Stephen Holty, and I'm a sustainability leader for Hemlock Semiconductor. And today I'd like to introduce you a little bit to HSC, or Hemlock Semiconductor, provide you our energy-intensive industrials perspective on decarbonization, and really help understand the Michigan market value of why we're decarbonizing as a society as well as an industry, and help plant the seed. That to reach the 2050 Paris Agreement, we need to really understand what our industrials' big pinch points are going to be. And just to give you the heads up about on-site thermal energy needs, it's going to be the biggest and toughest nut to crack for Consumers Energy, DTE, Hemlock Semiconductor, companies that need on-site thermal needs. So what we do at Hemlock Semiconductor is transforming people's lives by energizing and connecting our world. And I like to show people where we're located. Hemlock Semiconductor makes the bottom left-hand corner of the trapezoid in the Great Lakes Bay region of Midland Bay City and Saginaw, about 2 hours to the north and west of Detroit. We're approximately 1,200 employees, $1 billion annual revenue. To the north of me, directly to the north of me where I'm sitting, we have upwards of $3 billion of assets that we've invested over our lifetime. And what we do, we have a superpower to create, with this industrial plant, this really cool asset to create polysilicon, which is that U-rod on the right. That polysilicon, the supply chain is, we take quartz, which is silicon dioxide, and we don't actually take it in our supply chain upstream of us. Quartz is mined out of the earth. It's one of the most mineable minerals and one of the largest volume mined minerals on earth. And it goes through a smelter where we take the metallurgical grade silicon, 99% silicon, so 2 nines of purity, which would be 1 penny out of $1 impurity. And our superpower at HSC is creating the hyper pure polysilicon, so up to 11 nines of purity. And we actually, through the MMA, we actually won Michigan's Coolest Thing Award this past year. And that's our hyper pure polysilicon. And so that's really our superpower, is to go from 2 nines of purity to up to 11 nines of purity. And how we do that is through chemical vapor deposition. Chemical vapor deposition is that reactor that you see on the left. We use the most electricity in Michigan. So we put electricity through our reactor, and silicon is deposited onto the hot surface of a slim rod, growing the slim rod into the large rod off on the right. And that product then gets broken up into chunks, and we sell into the electronics supply chain. And our primary customers, most people haven't heard of, they pull the ingot wafer, but everybody has heard of the Intels, the Apples, and the Dells, which the computer chips that we help produce go into. And we have, out of Hemlock, Michigan, approximately 30% market share of that electronic supply chain. The solar supply chain, we started back a little over a decade ago with 20% market share, where our polysilicon was going into ingot wafer, and it was going into the solar panels that we've discussed earlier. And then back in about 2013, 2010 to 2013, tariffs were imposed, trade wars, and we stopped being able to produce solar going into the supply chain, or polysilicon going into the solar supply chain. And we really started paying more attention to the end user, which is part of our sustainability story. Is through 2 administrations at the federal level, we tried to remove the tariffs of being able to sell solar into the supply chain. And we found that it just wasn't working. So we really need to tap into what the rest of the supply chain was looking for. And they were looking for decarbonization. They were looking for cleaner solar, and we get to be a part of that story. So our primary competitors for the solar supply chain have been out of Asia and in China, and we have been making sure everybody outside of Michigan and outside of the US understands that our solar that we produce right here in Michigan is lower carbon than the solar that many have been buying. Not all solar panels are created equal. We help form the Ultra Low Carbon Solar Alliance, which is an alliance of manufacturers of solar outside of, or just low carbon, and they happen to all be outside of China. And that is our strategy, figuring out how to bring value to the marketplace. And I want to amplify to Michigan that we help bring value by having decarbonized electricity and by having these types of forums. So what is our remaining carbon footprint at Hemlock Semiconductor? So a small 10–20% fraction of our carbon footprint is from natural gas, and that's the thermal heat that we require to run our process. To get to ultra pure, to get to 11 nines of purity, we require many distillation steps. And distillation requires heat at the bottom of the distillation columns and cooling at the top of the distillation column. So that's our primary need in terms of scope 1 carbon emissions inside our fence line. Now, we are lucky at Hemlock Semiconductor because we are highly electrified already. So the vast majority of our scope 2 is from electricity of our carbon footprint. We're also lucky because we've been advocating, and the rest of the world's been advocating, and Consumers Energy and DTE have, here in Michigan, have been listening and have been helping us reduce over the next 10–20 years the carbon footprint of our electricity. But they will also have the tough nut to crack of their base load, which today is going to be natural gas in the coming 10–15 years. So over the next 30 years, to get to the UN goal, as our electricity grid continues to go towards zero and we make more and more innovations to understand how the electricity companies, how the utilities can fully decarbonize, we expect to fully decarbonize our electricity as well. But the tough nut to crack then as we grow is going to be our on-site thermal needs, because our natural gas, if we do nothing differently, is going to grow. So our carbon footprint in 2050, if we don't start now looking at our dependency on natural gas, we will end up with roughly 1/4 to 35% of our embodied carbon as we continue to grow over the next 30 years. So that's what I wanted to highlight, and how we are going to address our industrial thermal needs. In addition to purchasing renewable energy power to lower our electricity, in addition to energy efficiency projects, our industrial thermal need, really cracking that nut, we've been participating in the My Healthy Climate Plan. The governors put together a council on climate solutions, and I actually was nominated and got to help co-chair the energy intensive industry work groups, and we discussed our thermal needs at length, and we've talked collaboration with the utilities, and we talked with the American Chemistry Council, we've talked with the DOE. Renewable Thermal Collaborative has been quite instrumental in understanding where industry needs to go. The Global Electronics Council, I'll touch on them on the next slide, as well as CEBA, Clean Energy Buyers Institute and Alliance. The ACEEE has come and presented to our My Healthy Climate Plan and to the energy intensives to help us truly understand how to crack that industrial thermal need. And finally, as I mentioned, the Ultra Low Carbon Solar Alliance. So here is a snapshot of where we're at in 2021 with our scope 1 and scope 2. greenhouse gas CO2 in terms of metric tons. As we grow over the next 10 years, we should see, if nothing else were to change, we would see our greenhouse gases going up around 2 million metric tons with growth. Luckily, and we've been advocating as a society, as a company for many, many years now, our electrical grid is cleaning up right here in Michigan. So that's a tremendous competitive advantage as we install more and more solar as companies and as utility. Purchasing power and renewable energy is going to be a large part of reducing our corporate carbon footprints, as well as energy efficiency projects. And getting those grants and going after capital and continuing to beat on the drum of energy efficiency will help us get our greenhouse gases reduced over the next 10 years. But then remembering the final nut is going to be making sure that we're all focused on those fossil fuels that we've become dependent on as industry for the past 100 years. And I want to touch on our alliance. Part of the reason why we have been so successful at really framing how to make solar more and more green is we've gotten together with an alliance, and we are getting together and working with the Global Electronics Council, or GEC, to expand the Electronics Product Environmental Assessment Tool, or EPEAT. EPEAT has been so far a wonderful, wonderful tool. It hasn't had a lot of carbon. It has not included carbon to a high degree. So we are adding carbon in terms of purchasing solar or photovoltaics. We expect to launch that expanded Ecolabel of EPEAT, which includes carbon, mid-2022, so later this year. I've been participating in the technical committee where we're writing the rules and making sure that the life cycle assessment is detailed and well understood and using the best technology available. And the idea is to give buyers of solar confidence that they're buying better solar, as not all solar panels are created equal. And we believe this gives Michigan a competitive advantage, and we're going to continue making sure that people know about it. And it'll also help grow low carbon solar manufacturing through market signals, so that when buyers put out RFPs for solar panels, they can be asking the questions, what is your embodied carbon? And what does your solar panel look like from a life cycle analysis and carbon intensity versus other solar panels? And that is the majority of what I wanted to cover today. And what I wanted to leave you with in terms of the My Healthy Climate Plan is we in industry need clean fuels. As we electrify, we definitely need to understand where there's thermal needs, what those natural gas and other carbon or other fossil fuel replacements will be. So let's, as we do our carbon accounting, make sure that we understand that pinch point over the next 20, 30 years. And obviously energy efficiency. Energy efficiency will continue to be important for all of our industrials. And finally, make sure that you're buying clean. Make sure you're asking the questions when you're buying solar, when you're buying any sort of renewable energies, that you're asking the questions. How was this material, how was this equipment produced? What's the embodied carbon? And is it clean? Make sure you understand your options, because not all solar panels are created equal. And with that, I thank you. Any questions?
Thank you very much. Yes, we did receive a few questions. The first one, as your company was evaluating where you could reduce your energy consumption, what area offered the most surprising opportunity?
The most surprising opportunity. That's a really good one. We use the most electricity in the US, or excuse me, in Michigan. So we're highly energy intense in terms of electricity. And we put in waste wasted electricity recovery. And in doing so, we increased energy efficiency year over year, like 10% year over year back when we installed those. The biggest surprise for me looking back at the last 30 years is after we added those, we hadn't optimized them. Because fossil fuels were so cost competitive, we hadn't necessarily looked at our fossil fuel use to make steam. So fossil fuels and natural gas coming to our plant was so cost competitive, we hadn't looked at it. I was surprised that we had a lot of optimization in our process that we could do to save even more natural gas than we did by putting in that waste heat recovery. It was a big surprise, and it required me to be put into this role as sustainability leader and do the carbon accounting to find that surprise. And it almost felt like I was lifting up a rock that hadn't been looked at for years and said, have you guys seen this? And my peers out in the plant said, we hadn't thought about that. And it was because I was looking for carbon, not cost.
Interesting.
Going to save cost and carbon with those types of projects.
Wow, fascinating. It's really rewarding.
Yes, it is.
What tools did HSC use to help evaluate potential areas of energy waste reduction?
The number one rule, tools that we've used have been accumulating for decades. We have been data mining and using digital tools to put our plant and our plant energy use in databases for decades now. Our plant actually got ahead of the computer generation. We were putting our energy use into databases before all of our employees had computers and laptops. So before 2000. So I have the data for energy use well before 2000. And so that's quite exciting. So we have that as a baseline. In the last 3 years, we've partnered with TIBCO, and we have the Spotfire tool, which is a data analytics engine, so that instead of downloading all of this data into Excel, which would often start to crash because we had so much data, now we have a data analytics tool that we can study and analyze and look at visualizations and get insights to our data almost instantaneous. So the tools of digitalization, getting our energy data in databases, and then being able to see it with the latest and greatest analytics technology would be the biggest tools.
Very cool. Besides energy, are there other areas HSC prioritizes to improve its sustainability practices?
Yes, one of our obviously energy efficiency, but another one of our bedrocks now of carbon is doing our life cycle analysis so that we understand exactly which levers affect our carbon intensity. So we know energy is the number one. Number two and number three are feedstocks that go into our product, which are, for those who do the carbon accounting at your companies. I talked a lot about scope 1 and scope 2. So our feedstocks, which come in from where we purchase, are our scope 3s. So we know how important it is where our feedstocks are being produced and their grids and how clean their grids are. So we are talking with them and our suppliers about their carbon intensities and making sure that they understand that our downstream customers care, so they need to care. So those are pretty big levers, our scope 3s. And I'll also say that waste ends up being a smaller carbon intensity, the waste that we send, because we've been hitting waste and we recycle so much that we don't have a lot of waste coming out of our plant. But there's always opportunities, and reducing all waste to its lowest environmental impact is one of our goals. It's not going to be a big carbon intensity hit for us. However, it's the right thing to do for the planet. And our people do get energized about it, which is really cool. I give them all of the big data about how to move the chains in terms of carbon, and our employees want to recycle the cups that they see. They want to make sure that we're using, you know, coffee mugs that they can wash instead of polystyrene, which they know is into a landfill. Yeah.
That's great.
Yeah.
Can you talk a little bit about how HSC empowers all of its employees to suggest ways to for the company to be more sustainable and efficient? You already touched on it a little bit, but anything else?
Yes. I've been tasked with laying the groundwork for just that. At first, when sustainability leader was announced as a job, nobody really knew what it was. And when I took the role, after 23 years of helping to run the plant as a chemical engineer and as a leader, it was assumed that Stephen is going to do all the projects for sustainability. I was going to move all the chains. And I think that's kind of a natural assumption. My role is to set up the systems so that we can value carbon, we can value the people, the planet, and prosperity, the triple bottom line. We can value our ESGs, environmental, social, and governance, and that we can set up our systems so that all of our leaders and all of our people can do projects, can move the chains, and have them valued. So that's what I'm doing to make sure that all of the people in the company know that they can be a part of moving the chains with me. So we have the blueprint. For years, the blueprint was that's our management tool for getting the executives on the same page to get the company running in the same direction. And we've got carbon intensity on our blueprint. We have our green print, which is how we are generating pull through demand to make sure people know that that not all solar is created equal. And that is another way that we're empowering all of our employees. We write down what the direction is, and carbon intensity is definitely part of it. Energy efficiency is part of it.
Great. And last question, how much more efficient were you, how much more efficiency were you able to recover? Are you able to create a digital twin of your facility?
Our CTO actually talked to me about digital twin the very first time that I got in front of him. The digital twinning is definitely on its way, and we have Aspen modeling, and then we have Spotfire modeling. And so digital twin is on its way.
Cool.
What was the first part of that question? I want to make sure I got it.
How much more efficiency were you able to recover?
So we've got 30 years of efficiency. We had, back when we put in our energy recovery about 20 years ago, like I said, 10% year over year. Then for 15 years, we were a almost 1% year over year energy efficiency company. And what my executives have challenged me to do is make sure that we get to 1% year over year, which means we should be setting 2 to 3% year over year goals. And as a benchmark, if you were going to stamp your product Energy Star, you would have to be on average 2% year over year. And we are looking at becoming Energy Star partners.
Great. Well, that wraps up the questions. Thank you so much for joining us. It's really fascinating and inspiring to hear all of these presentations. Thank you very much.
Thanks for having us.